past primary fx lambda times fx lambda all that. So ndio nasema ni product ni product. Si unakumbuka venye tulisema itakuwa lambda n hii ni factor minus lambda c minus lambda n summation. Sasa hii ndio inakuwa sand.
Yes.
Kwa likelihood ratio unakumbuka tuna introduce log. Ndio tutoe hii exponential. So unakuwa na lambda equals to, so introduce itakuja n log log lambda. Hii inaondoka. So
yes, ina drop yote.
So from there now we go to differentiation. In respect to lambda. Itakuwa n over lambda. And then minus lambda itaenda because lambda is in respect to lambda.
Yes.
So minus summation this. Then you're supposed to equate to 0.
Yes.
This, whatever you get here. So n minus lambda, this is equals to 0. So now you want to make
lambda the subject.
Yes. So if you take his side, it'll go n over lambda summation x side. Then you have n is equals to, so you just try to manipulate to that lambda.
Yeah.
So now, on the end, summation x side. So hapa ndio sasa from there with that tunaanza substitute. N is equals to 3.
Yes.
So na substitute your summation of x i. N is equals to x i tumetoa ni 135.
Yes.
So unapata
something. Okay. Yeah.
So unabaki with the 1 over 3. Na 3 over 9. Which is about. Imeenda. Ndio na hii imeisha. Hapo.
Yeah.
When you're checking for the second derivative, you normally check the variance. And you'll be deriving from where did we stop? Where our idea about our this one.
N over lambda.
This one. When you get the second derivative in respect to lambda, unajua hii itakuwa nini? N over lambda squared. Si kama utakuwa umepata kama itakuwa yes, na hii itakuwa 0. Na hii lambda.
Derivation. Differentiation. Ina reducing ama inaongezea?
Second derivative. Unajua hii ni kama minus 1.
So minus 1 inakuwa minus 2.
Yes, so it is the same as 1 over n over lambda squared. So you know, yes. So n greater than 0. Because for n is not less than 0. See, n to share only
3.
3 years. So it has to be greater than 0. So lambda is also greater than 0. Of course. Because you cannot divide anything with a 0. That be the case. So even this lambda squared you have to be greater than 0.
Okay.
In a case. Yeah, if it is undefined, even if divided by 0. So it has to be greater than 0. Right?
Yeah. But also something else. Siko tumepata lambda is equals to n over summation of xi. Right? And from what we calculated, tulipata is equals to 1 over 3. That is the value of lambda, right? Which is greater than 0. Can that be the argument?
Yeah, that is true. But I'm saying, for these, I always divide. Unajua lambda is already defined, so I use it as zero. Yes, the way you're saying is that it cannot be, because hata ukisema ni zero, unajua hiyo kitu haiwezi kuwa realistic.
Therefore, the stationary point is indeed a maximum. So in a situation, it was zero, it would mean it's not a maximum. Okay.
So hiyo nataka tukitoka hapa quickly tuende kwa ile nini? Ile inaitwa nini?
Tunaweza rudia ile ya kutafuta A and B. Juu hiyo kidogo usiku capture. Nataka kuflow nayo. Ile ya kutafuta A and B. Ile y is equals to A plus bx.
Wana tu kuifanya sivyo?
Ilikuwa question 1.
Question 1? Tulikuwa tuna demonstrate na tulisema maswali ya mwalimu tunakama tukalculate sisi wenyewe.
Tukalculate sisi wenyewe ili tuone whatever we get kama ni the same na chenye mwalimu alikuwa amepata. Si mwalimu Gemini, God. Ewo.
Tulijaribu kuattempt kama ilishinda.
Kani?
Hizi za jana.
I had one. Innovation sio ni kama tulifanya.
Kuna vitu tu tayari tu mtu anaona. Unafanya enough sijalala.
Acha.
Shakuwa naisi ati kulala ati usingizi ya kwenda hakuna kitu siwezi kwa ati.
Me, I slept soundly.
Usijua alikuwa anabang nini.
Umepita hiyo swali huko juu.
Hata nilikuwa nataka tu refresh. I was only trying to refresh what we had done here. Kwa hiyo ile tulikuwa tuna substitute hizi vitu si ndio as they are. Shida ni kusahau. Unajua kama terms metropolis, step.
Me actually hizo terminologies mara mingi zao unichanga, ndio determine ndio hiyo. Ndio hiyo. We have 3 observations. So that is x and y. So x has 1, 2, 3. Y has 2, 3, 5. So if we were to put in the equation, itakuwa ya kwanza ni y. Inafaa kwa 2y is equals to, right? Si 2y. Ni 2 is equals to a plus b. Nataka tu kuunderstand venye tunatengeneza hiyo H transpose. At least nilipata venye kuna hii value fulani tulikuwa tunaweka value za ni y ama ni za x against 1, 1, 1, 1.
We are saying
lakini hebu fungua swali deterministic. Ilikuwa kwa deterministic. Huku kwangu kuna kuanga na umbo, my lord. Lakini nitanunua mosquito net na venye nilikuwa nimekataa. Second floor. Si according to huku kwetu mimi ndio nakuanga the highest huku juu.
Second.
Yes. Hii yenye iko na error So ile swali yenye ina error iko juu ya hii.
Sasa ilikuwa na error term.
Iko na error term.
Hiyo iko na error?
Hiyo yenye tunasoma sasa hivi? No. Haina.
It's just that one.
Yes.
Iko na A and B.
Ndo hii. I think ndo hii yenye tulikuwa tumefanya. Ndo hii. Which I have here. So we make a H.
You create your H.
So
which is one. I mean this and this silent one here. This one C also do one all that. Then you have your X, which is now depicted by the unknowns. This unknown M and C.
Which our unknowns are B and A. Now question is, unafaa zifuatanishe aje? Because we ameanza na M and C.
Unafuata yenye iko na nini? The X is the variable, is the first one. Yenye iko na the X, CX already ni hii ya 1X. Ipata 1X, XM. X, 2X, 2X. This hii ya 2 ilikuwa bado X. Na hii ilikuwa X. So hii ya first iko na M. Yenye iko na variable X.
Okay. So in our case, we will start with B and A. Because our equation was y is equals to A plus BX. This is not it. This is not that question. B sawa. Alafu ingine ni gani? Ndio hii sasa. Alafu y is equals to will be 2, 3, 5, right?
Sasa unajua mimi niko kwa hii sasa I'm not sure. Maana kile kitu nimekuja kitu. Hiyo na y as it is.
So sasa shuka chini. So we compute H transpose H. E, whatever it gives us, it will give us 1, 2, 3, alafu 1, 1, 1. The transpose yake itakuwa ni 1, 2, 3, 1, 1, 1. So this is a 2 by 3, 2 by 3. Ingine ni 3 by 2. So we will get a 2 by 2 matrix. Okay, so we multiply. It's 1 times 1. You add 2. 2 times 2. You add 2. 3 times 3. Okay, hiyo tumemaliza moja. And then bado tufanye hiyo 1. 1 times 1. You add 2. 1 times 2. You add 2. 1 times 3. I hope na follow nisikuwe na kuchanganya, si ndio?
I suppose I've displayed this, so I'm only listening.
So 1 times 1, you add 2. 1 times 2, you add 2. 1 times 3. And the second one will be 1 times 1, you add 2. 1 times 1 again, you add 2. 1 times 1. So we will get 1 plus 4 plus 9. That should be 1 plus 4 plus 9. That should be 14. 1 plus 2 plus 3. That is 6. This one is 1 plus 2 plus 3. That is another 6. And then 1 plus 1 plus 1. That is 3. Okay, yes, we have gotten a 2 by 2 matrix. Okay. So,
1 times 1, 2 times 2, 4.
3 times 3, 9,
9.
So we go to H transpose times Y. H transpose ni ile bado 1, 2, 3, alafu 1, 1, 1. Alafu Y is 3 by 2, 3, 5. So this is a 2 by 3, na hii ni a 3 by 1. So you'll get a 2 by 1 matrix. So hii ni 1 times 2, 2 times 3, you add 2, sorry, and then you add to 3 times 5. The second one will be 1 times 2, you add 2, 1 times 3, you add 2, 1 times 5. So we get, this is 2 times plus 6 plus 15. That will make 21, 23. 2 plus 3 plus 5. That is 10. Okay, up to there we are together. Solve the normal equation. So sasa tunashikanisha, tunasema H transpose H you multiply by X prime is equal, should give you H transpose Y. Okay, so we can say the 14,663 you multiply by A. We said BC, right? BA. Even the X yetu inafuatana. Should give us 31, 23, sorry, 10. So when you start multiplying, you get 14B plus 6A should give us 23. Na ya chini ni 6B plus 3A should give us 10. So we solve the quadratic, right? Tutumia hii ya chini inakaa rahisi. 3A is equals to 10 minus 6B. You divide by 3 everywhere. So A is equals to 10 over 3 minus 2B. So replace kwa ile 14B plus 6 into brackets 10 over 3 minus 2B is equals to 23. Makes 14B plus 60 over 3. Badilia chini kuweka 220 minus 12B is equals to 23. So 14B minus 12B ni 2B is equals to 23 minus 23 over 2 over 2. So B is equals to 1.5. Hivyo ndio tulipata. Hebu rudi kwa hiyo lecturer. Ya Gemini, pole guy. I keep forgetting, man. B ilipatikana kwa nini? Yes. So utatumia hii ya lecturer. Juu A sasa si ni kureplace tu na A tulisema it's 10 over 3 minus 2B. So A is equals to 10/3 minus 3. Okay. This one will give us 3 and 3. So A is equals to 1/3. Yes, correct. Now, that is good. Captured that very correctly. Huku rula zangu kweli zina existing. Rulers. My son. Oh, yes, sir. Okay. Mm-hmm.
Measure that discrete type. You want to fit a quadratic model. Sasa hapa unajua I wanted to show you what has happened here.
Mm-hmm.
So let me show you.
Hey, hii kwanza ni ya 3.
Tafiti kwa hii equation,
Mm-hmm.
Unaona? Sasa hapa unajua sasa hapa amezichukua venye ni kama unafaa uchukue venye equation ya kusemekana.
Una make sure y ndio iko huko mwisho.
Nasema depending with imeanza na A, B, C, ile ingine iko inaanza na B.
B, A. Yeah.
Whatever was first.
Yes.
I think. So no. So this one is just the same way.
All right.
Apply for it.
Kwa hivyo hiyo ni kitu chenye mtu anafaa kubeba.
SE is H transpose H the first thing. Then H transpose Y.
Alafu you multiply by an X hat should give you
amesha calculate. So is the final thing. This one. Yeah, H transpose H is matrix H transpose that. So when we get the X hat, so this one H transpose inverse ndio tulikuwa tuna calculate for the determinant. So you get all that. And now just a moment. The deterministic least-square model is identical. Do you know what a deterministic is and that's stochastic?
But I think there's a question to that effect that is trying to compare those two.
Hii ile unakumbuka ile ilikuwa ya JX. Unakumbuka hii tulifanya yenye tulikuwa tunasema ya symmetric. Hii tulifanya.
Oh, ile ya error.
This one is symmetric. So ukumbuka to treat hii symmetric, but you see here sasa kwa hii when you are squaring the error. Nakumbuka sikumbuka ile ya error square. So nataka nikuonyeshe kitu kingine hapa tu. Hiyo tu tunajump nayo.
Kwanza kwa hii swali I had a question. Hii ingine ilikuja aje tu as you're deriving inakuja tu hebu shuka.
Si tulisema ni kama A transpose na transpose is the same. A transpose na A they are being treated like is a square here. Na tukisema hivyo like A is a square ndio maana already tuko na A na 2. Lakini A transpose ndio ina drop. Is it transpose ama ni one of the x ndio ina drop. Okay. X transpose ndio ina alafu x moja itabaki hapa. Nakumbuka. We discussed it at length tukiulizana how the two is coming in here.
Okay.
So, hebu nikuonyesha kitu hapa. Show another methodology hapa kidogo tu. Unaona bado ina resort to this. So it's actually coming back to A transpose A. Similarly, tulikuwa tunasema H transpose H. H transpose Y.
Okay.
Na kitu kingine nataka tuulizane hapa, hii ni nini sasa? Kwanza tusome hii maswali tu, si ndio? Because sasa tuko na concept. Example, estimating a constant parameter in a noisy measurement. You are trying to determine an unknown constant voltages. You make 3 independent measurements, yi of the voltage. However, the measuring device adds random error. Random zero mean noise. Vi with the variance that. So the mathematical model that you get is this. So the linear equation, where this is your error. So suppose your noisy measurement, y1 is 10.2 volts, y2 and y3. So solution. When you define the error. So in this case now, when you're asked anywhere about the error, you never need to make error the same. That's why we are saying is yi minus x bar. So we pick the cost, the error when we usually always aim at square, making minimizing the error by squaring the error. So by minimizing the errors squared. Sum of square errors. That's why tuna square hii error yi minus x hat. Then when we minimize sasa tunarudi kwa when we minimize, lakini sasa I'm surprised. Mbona hii sasa hatujafanya kama ile ingine yenye tumemultiply out?
Kufungua.
Ile kufungua. You know ameenda direct.
Kuderive.
X hat. So itakuwa ni minus, of course minus 2 because there is a minus.
Yeah.
Just want to do what she's up to very quickly. Next one is so for the estimate x hat. Now this so see sasa tunaweza equate to 0.
Yes. Because you've derived, right?
Because it's a 0, yes, you can say divide by 2, divide by 2. Ndio maana unabaki na summation. And then we are 3.
Mbona x imetolewa hapa?
X hat. You make it the subject.
Mbona umetoa kwa summation na umepeleka bila summation? Does it make sense?
Remember?
X bar is a constant, but still as a constant when there's a summation inafaa kwenda na n. So badala iende na I get what alifanya. Alifungua akapata summation of yi minus nx bar x prime, sorry, akaleta ikuwa na hiyo 3 huku, which is our n, and then akadivide by 3. That's why we are getting there that. Okay.
Hiyo summation yi haina haina iko sawa. 3 ni juu ya hii constant ya hii x bar, ndio. So sasa unaweka venye ziko y pale, sasa we are summing the y's.
Yes.
Na nitapewa. Mbona hiyo venye imeingia na? So unapata hivi. Kidogo tu. Kuna swali iko hapa sijui tu. This one now. Haya, acha tufanye hizi. Hapa kuna formula kingine kako hapa. Nasema this one now is about hiyo tulikuwa tunafanya all along the board. Deterministic stuff.
Wakati tunatafuta values za the constants, right?
Let me ask, what is the difference when you're having stochastics and deterministic when you are doing the calculations?
Okay. Ukitumia sijasoma.
Si tumefanya hizi vitu zote. Unaona kama hii, hata nikuonyeshe tutavitu tu hapo pia. This handout, unaona hii handout ya the six. Deterministic least squares is a mathematical method used to find the best fit carbon parameter set by minimum set by minimizing the sum of square difference between observed data and values of predicted by a model considering potential issue. Data ni deterministic hapo. Nataka tufuate ili tuone ni nini tulikuwa tunasoma. Deterministic. The solid no equation. The same thing we have been using. Sindio? Kuone kama kuna hii difference. Fit in a linear trend. So this is all indeterministic. So whatever we have been using. Sindio? You already tushafanya deterministic. Advantage at deterministic, it yields identical estimates. You've applied the same batch, then it is really flexible. It is not limited to lines. And it's not only for linear. It's not only limited for linear equations. It can model any relationship, even others. So here it's deterministic. Deterministic. I think here to the square ilikuwa na ax is equals to nini? Unaona hapa?
Sio ni error tuliweka subject, after kuweka error the subject.
Ona equation yake. An overdetermined, even an overdetermined linear system. Ax is equals to y. Naona tulikuwa tunaulizana ni gani hii tuna square na ile nyingine anaenda direct. That's why you ask, you see this the kind of a format. Hii ax over y unakumbuka ni moved. Just in case I enter the same thing. Tusaidia. Si hata hii tumemake error the subject to square. Kuna kitu kama hiyo lakini hatukaenda this direction. That's what I'm saying. So hapo bado ni deterministic. Unaona? Nataka tuone what is the difference when you ask about deterministic. Deterministic imefika hapo. Stochastic now. These are statistical and a control theory method used to estimate a known parameter or states in the presence of random noise. Sasa ile ingine unaona tulikuwa tuna reduction of error observed and predicted data. Or deterministic. Lakini sasa hii is between the statistical. These are statistical and control theory method used to estimate unknown parameters or states in the presence of random noise. A statistical and control theory method, it is used to estimate unknown parameters or states in the presence of random noise. So hii inakumbuka mambo ya random noise.
So hiyo ni moja. Kwa deterministic hakuna random noise, but kwa stochastic kuna random noise.
So the objective is to minimize the expected value of the squared estimation errors.
Okay.
So it minimizes the expected mean square errors between an unknown parameter and the measurement. Almost the same thing. So hapa unaona hata sasa bado tumerudi kwa hiyo equation. Kwa sasa nadhani sasa equation hiyo itakuwa na noise hebu tuone. Estimating a constant parameter in noisy measurement. Nasikia hasa hapo. Haya, tuone. So this is the equation now comes with noise. Ile ingine haikuwa na noise. Umenotice? Ile ingine ilikuwa tu anomaly
a constant. Na hapo kwa via ilikuwa ni constant. Sini a plus bx.
So the normal unajua normal linear equation haina error, haina error iko tu b and two unknowns or bx plus as a constant. So I think when you see an error now, this one is stochastic.
Yes. Yes.
So you know how to define the error. So I think now, because this is now specific to the error, tukafanya hivyo. Umeona tofauti? Yenye tumeulizana ni aje sasa, si unaona?
So that is where the difference is. Ile we square the error, but for this one we solve for the error. Twaisema hivyo? Okay.
So now hapa, this is where now we are showing something else. Whatever I wanted to show you, sequential recursive stochastic estimation. So wacha tusome B, real time step by step sequential maswali. So kwanza tusome tu kidogo. Real time step by step sequential estimation of states in a dynamic system where parameters change over time. It's a real time step by step sequential estimation of states in a dynamic system where the parameters change over time. Instead of recalculating all past data, use the recursive update equations. In stochastic estimation, you want to continuously update your estimate as new noise data. That's new what is this? Admire arrives. As new data arrives. So for stochastic recursive, you want to continue recursive. You want to continue cleaning that data as it arrives. Suppose you have a prior estimate of a parameter x along with its uncertainty, and you receive a new measurement y corrupted by a noise. So prior estimate is that with error. So what does that? This is where the concept is coming in. So tumesema real time step by step sequential estimation of states in a dynamic system. Real time step by step sequential estimation of states in a dynamic system where parameters change over time. Instead of recalculating all past data, instead of recalculating all past data, use the recursive update equations. So you will not use, instead of recalculating past data, so you use whatever is coming in and being updated. So in stochastic estimation, you want to continuously update your estimate as new data arrives. So suppose you have a prior estimate of a parameter x. Suppose you have a prior estimate of so prior is x along with its uncertainty already. Already got uncertainty, and you see a new measurement y corrupted by noise. Your prior estimate x with error variance p. This is now p minus is the prior error, the prior knowledge. The prior the variance is the prior variance. So the new measurement now would be y is equals to x where noise p has a variance. The new one now. Yes. The other one had p minus prior. So now we have a new variance r. Okay. So solution. So the solution, what is the solution? So solution, stochastic least squares provides sequential solution. It provides a sequential solution, a fundamental form of the Kalman filter, where the updated estimate x hat is a weighted average of the prior estimate. Where the updated estimate x hat is a weighted average of the prior estimate, and then it will be combined. Combined of the prior the new knowledge, the updated one, and the prior knowledge. This is the prior knowledge, and now the updated one.
Okay.
After putting Kalman, which is our K there. Right?
But then tumefika hapa sasa nimepotea. Unaielewa?
Yes, you see, we are saying for this one, it combines the previous one and the new one, right? It continues even to update the new data as it comes, considering even the previous data has been some errors. So it is still updating as even the new data comes.
Okay.
So stochastic least square provides sequential solution. It's sequential because it's still going on using Kalman filter, where the updated estimate X hat, right?
Yes.
Is a weighted average of the prior estimate and new measurement. The new one now will be the prior plus the new measurement. They will be combined. That's why to be honest. So this is the new one, and itakuwa na the new measurement and the old one.
Okay. And the error as it flows.
Yes, and the error as it flows. But you see now the Kalman comes in here because this is the one that is doing always updating. So where K is the Kalman gain. So it is calculated. So the Kalman will be the previous variance over previous variance plus the new variance. This formula ndio nilikuwa nataka to capture.
Okay.
So Simona, where the P minus is coming in, we have the previous variance. So the Kalman it's a culmination of the previous variance over the previous plus the new variance. The new updated data. So now in this case, and the updated error now, variance, see now the updated one, see after we have done Kalman, since we will not have the P minus, we'll have the P plus, the new variance. It's a new variance. So the new variance will be 1 minus K, 1 minus Kalman, and the old one.
Okay.
You know, I saw it was like a simple thing. That's why I think nataka ituache tu hivyo kitu yenye tunaweza apply pale. Sinaona?
Yep.
So this is for the recursive one. The that one now. See the difference now?
Yes.
So we have an example very quickly. Your prior estimate, CBX, this one, is equal to 20 with the variance 4. The previous, you know, the P minus 4.
Yes.
So you get a new measurement of 25. No. And the measurement is variance is R is equals to 1. So what is our Kalman? Kalman tumesema ni P minus over P minus plus R.
Yes.
That's how this one comes in. P minus over P minus plus R.
Okay.
No.
That is easy.
That's why I say need understand it. Then calculate the updated estimate. Calculate the updated estimate X hat. So our X hat kale ka formula sasa. Inataka sasa tukaweke kwa 3. It is culminated of the old estimate plus the Kalman calculate the new one minus the old.
Okay.
Right? Kalman was very intentional. Tulikuwa tuna calculate Kalman wanakuja hapa. Haya, hii estimate ya kwanza tumesema it is the new estimate is the old estimate plus Kalman into the new minus the old. So tunakuja hapa na substitute. So this is the old plus our Kalman.
What we just got.
The new, there is 25 minus 20. So it's like we are getting the difference. The difference of the Kalman is actually working out with the difference between the old and the new. Right? Yes. So unapata 24. Now tukasema updated hii ya P plus. Sasa hii ni go to formula Mungu shuka. Hii just
formulas ni twingi.
Sasa the new P plus hapa itakuwa ni 1 minus Kalman times
the previous.
The previous. We just substitute, imagine.
Na zote unapatiwa. Zote unapatiwa. You just need to know the formula. And then you just insert the numbers.
So when to use stochastic is use stochastic. Use stochastic least square estimation when you need to predict an observable random variable based on noisy random variable observations. So where there are noisy observations is where you apply stochastic. Right?
Yes. Just 1 minute nitengeneze mtoto. Yeah. Let's go on.
So you have a formula. You run your formula. On a key characteristics here, stochastic. Minimize this mean square error. The estimate is chosen. We don't even need all this. We have a glimpse of it.
Yes.
So tumesema kitu ya kwanza ya kujua tumework out we are supposed to have the old kuna hiyo old
yes the previous
previous
yes
but simeona si kitu kama mtu atakumbuka formula So this is the new estimate. The updated estimate.
Yes.
So tumesema the estimated tunaiweka plus the new one, like whatever you get. It is the old one because inapata old one ikiwa existing. Plus there is an element of Kalman and a clean up. Then tunapata the new minus the difference.
Yes.
The hard video. Then we calculate Kalman. We say it is the previous variance
over the
P
previous plus the R.
Plus R.
R is the rate. Ama ni change.
Hapa ile kitu iko the minus peke yake ni hii ya difference y minus x hat.
Okay.
Tuta tuone kama that is true. Plus the new variance. Sio? Tunapata Kalman yetu. So when you ask now to calculate now for the updated variance here, now the P plus. So itakuwa ni 1 minus Kalman multiplied by P minus. That is it. Tuendelee sasa you can do the quantifiers zenye umeshika ukiniambia.
Yes. Kini the best thing ni kukubali.
Wacha tukubali.
Yes. Tumemwachia the rest. Hata Mungu mwenyewe anaona we have tried.
So twende wapi? So hii tunasoma wapi?
Hii iko kwa ilikuwa inaitwaje? Introduction to estimation. Ndio hiyo hapo juu.
Iko na theory. Okay, not theory but somehow it's theoretical. Si tukisema tuanzie 5.
Okay.
Fanya zile maswali 4 to 5. Then from 5 we do that whole thing of estimators.
Okay. Sawa.
So maswali tulikuwa tumefika wapi? Tupitapitie tuone kama tutashikashika zingine kama tano. So what is here?
Tena after tulifanya swali hii swali ya linia, kuna kitu kingine tulifanya kweli?
Nataka nione ni nini hizi zingine Rachel tu.
Wakumbuke ukimwambia turanie.
Ndio nataka nione what she read.
The way I am tempted kukwambia ikifika around 5:30 nirudi kulala. The way I'm tempted.
I don't even think of that direction. Mimi siwezi ingia kwa hiyo. Nitaenda kulala kwa nyumba. Hapa kuna
hatutakuwa mazombi at some point.
I don't think so.
Okay.
Sasa ukishaamka umeshaamka sasa.
I wish my water was cold. I wish maji yenye nakunywa ingekuwa baridi. Ingenishtua mara 2-3. You know you're not projecting anything?
I am not.
Yes.
I am saying.
Mimi nasikia tu kusema what are these? So na ndio nimeshangaa. What are you looking at that I'm not saying?
Tunasema zaidi ya not struggling with them. Tunafanya ile vitu inaingia. Kitu tulistruggle nayo hata kwanza tusifanye hiki. Hiyo tumekuwa tumestruggle na hiyo smooth energy. Na hizi vitu.
But hiyo LMS unakumbuka tumeifanya na ikaflow.
Igani?
LMS. Hebu panda juu. Slowly. Hiyo. LMS adaptive filter. Update rule. Tumefanya swali ya hiyo and it was very easy.
Zile za kusubstitute.
Yes.
So this one has I don't want to. Unajua hiki kitu tulifungua na Rachel ikafanya tulale hapo bila not crack. Vitu ziko hapa. Unaona?
Yeah, we. But unajua ikifanya hivi inakaa ngumu. But then when it's in a question and then you solve it, it's very easy.
But it's now here they are only stating these things. We don't want things that are scaring us too much beyond repair. Acha tuone hii swali nyingine jamani. 25 pages. Oh, yaki ya booked.
Still not sharing? Not sharing.
Yeah.
Oh.
I'm sharing. Jehova tufanye tu kitu tu miujiza nikumbuke zile vitu tumefanya so hii ni question 5.
Jaribu kuamsha last born. Ni last born ama ni second born?
Who is that?
Rachel. Si alisema aitwe? Yeah. Tuendelee.
Sasa jaribu kujiuliza hii swali inakaa aje? Which question is this?
LMS adaptive feature. Si ndio hiyo yenye tumefanya hapa?
Nataka kuangalia kwa hili kwa hizi notes. Unajua sasa hii tumechanganya. Which question is this?
Nimeona kama ilikuwa question 4.
Inaangalia which 4 is this? Tunaenda kwa hizo 4.
Msichana hajachukua simu.
Unaona hii tumesema ni hiyo ya nini? Na by the way, kidogo Josephine. Kidogo.
Hatukuisoma actually.
Just a moment. Sorry for hoping.
No, it's okay. Ilikuwa iko deterministic. I'm not sure. I'm just thinking.
My guess is right. Kidogo tuone what happened. Nakumbuka tukiulizana alitoa 1x 1. Tuisome tuone. Suppose a local electronic retailer wants to predict monthly sales based on their advertising budget. We collect N is equals to 5 months of historical data. So the budget is that. Matrix nutrition setup will have a Y. That one is okay, and we have an X.
Yes. And we have the base.
The number of coefficients, B is the vector of a known coefficient. Then the error. So in the picture, Y, then of course we have E. Sasa unaona hii ni nini
imechange. Kwanza tufanye transpose ya ini. Ni just as it is.
Unaona hii? Unaona hii imekuwa 1x1. Na ndio bado inabeba the unknown. B not.
Yeah, it is not plus. It is like it's a multiplication.
Nasema sile ikiangalia x haikuwaga like a 2 by haikuwaga 5 by 2 matrix. Initially.
Yes.
Hapa ikiwa 2 by 2 by 5. I mean a 5 by
5 by 2.
5 by 2 matrix. Ile ilikuwaga tu a column vector. Sikiwa tunasema ni x1 x2. Hebu hata tulikuwa tunaona tofauti hapa inaweza kukoroga msi. Sasa tofauti na because ile nyingine tulisema hebu nisome ile uliandika kwa book. How you are picking the constant with variables.
Yes, ilikuwa ni y is equals to a plus bx.
Y is equals to
a plus bx, a constant a. So hapa tunaona hii ni bx plus error, but the constant it's an error we are working with.
So that we want us to see how we pick what here. You get it?
Yes.
Here, you are finished.
You know, naona kama we are picking the same way. Because tunakumbuka when we make the equation y is equals to a plus bx, right? Hii value ya h, how are we doing it? We are taking the coefficient of b, tuseme ni 2, and then the coefficient of a inakuwa 1. Unaenda hivyo hivyo.
This one, what kind of an equation do we have?
It's still a quadratic equation.
A linear one. With an error.
Yes. Now instead of the constant, now we have an error.
So like it's like the anticipating. We have here. We have how many? Tumeambiwa ni how many unknowns is b beta naught and beta 0. So it's like we have it y is equals to beta naught plus beta 1 x plus error.
Yes. Not beta. Yes.
So beta naught plus beta 1x plus error. Wait.
Yeah.
So with that in mind, so we'll be having y1, that one. Then we have beta naught and beta 1.
Yes.
Sasa our x, hapa x ndio nasema sasa hapa. X kwa hii bona tulikuwa ikakuwa ni 1x1, 1x2.
Zika interchange. Juu ingine tulikuwa tunafanya x1.
Kama ni venye tulikuwa tumeambiwa hapa, design of the matrix is n times p. Where p is the number of coefficients.
N times p. Okay.
So it is the rho times n and then times p times, so it will be 2 because see there are two variables.
Yes.
Haiwezi chukua ni moja ndio iweze kusolve. CP is the number of coefficients. C is the number of coefficients. And the coefficients are 2.
Yes. B naught and B1. Yes.
Yeah, times 1.
Okay.
You see what I said about why like we need to be. So when it has to be this way, then by P. So you have to say, so it automatically picks 1 because it didn't have anything. It was like a silent 1. That's why I think it was 1x1 or something. But unajua hasa kwa B naught, unajua B naught sasa inachukua ina assume 1. Yeah. B naught by the end 1. Like B1 equal to x coefficient. Yeah, it is okay. It's the same thing. Yeah, no? Yeah, no?
Yeah. I get the big difference, man.
You get it? So
yes.
With that now, kidogo tupitie kidogo tu. Our issue is to have x transpose x.
Yes.
And then x transpose y, h, whatever. That's why we are having x transpose, transpose our x.
Yes.
X transpose by x. See, x transpose x. Then we also have x transpose inverse. You get the determinant.
Yes. That's my prayer, Joel.
Naona inakuwa that matrix, so lakini hapa hii d inakuwa d minus ndio.
Yes.
Then one of the determinant. The determinant is the leading diagonal minus the second diagonal. And then you calculate x transpose y. See already easy to pronounce. Now, alafu sasa unakuja kwa hii beta hat. Na apply hii hizi zote tuko nazo. Na substitute.
Okay. Wow.
So you get the coefficients beta hat. So beta 1 nayo itapatikana wapi?
Ni ya pili. Yaani hivyo venye zimefuatana. So nakumbuka tulikuwa tumeweka B naught B1 kwa ile equation ya pale juu. Hebu panda utaiona venye tulikuwa tumeweka. Panda. Hapo. So tumesema hiyo ukimultiply by B naught B1 inakupatia.
Here there are 2.
Yes. So hivyo umepata moja juu moja chini. Hiyo juu ni ya B naught, hiyo chini ni ya B1.
Oh yeah, ndizo hizi. So it's okay. I think we can go back. We can retreat to where we were. And it was a good thing. Sasa hii unajua sipati hii swali.
Kuangalilie kama iko hapa ama Esther kwa construct maswali za kwake. Rachel, nashindanga nikiconfuse, nikikwambia mambo na Rachel nasema Esther. Iko kwa, hebu enda kwa maswali hiyo theory. Umeenda kwa maswali? Should be, I think page 4 or 6. Ndio. Yes, there you go.
This is a different one.
No. That's a different one. It's not the one we did. And this one is the one you yenye Esther ameweka. Rachel ameweka.
Unakumbuka hii ndio tulifanya, si tulisema this is very intentional. Yenye tulicalculate for YN.
No. Haya. Yumini swali imejirudia.
YN is equals to YN. Tulisema ni na wenye tuliso.
Sasa nakumbuka tulisema YN, to get a YN we take W transpose, you multiply by XN plus 1. So in this case hatuna plus 1, so tuna multiply by XN. So it will be WT, where is WT? Ni 0.5. You multiply by XN 2 1. Na hii 0.05 inafaa kwa diagonal. Then when you multiply, what it gives you a YN. So when you get the YN, okay, it helps you get the error.
One moment. Just a moment.
Okay. Oh.
So kuna venye tulisema EWN na XN iko very intention.
Yes. Yes.
Na hii YN inatusaidia WT. So actually now the catch here, the catch 22 is about the transpose.
Yes.
So we'll interchange this. But this is already a transpose.
That is just it. So transpose tutaiweka ina diagonal. Iache kukua ina vertical ni gani? Tutaiweka vertical ni kwenda na chini, si ndio? Ukiweka hivi vingine. Yes.
So it's horizontal.
Yes.
So
multiply by 1 2.
Transpose.
Yes.
Times x. Then hiyo YN venye tumeipata ndio tulitumia hapa kwa error.
Error ni dn minus yn. So when you get the error, so unarudi kwa the main equation. But now no, it's not the same thing. Yeah, here you go. It's not. Hebu shuka uone ama upande uone equation yake si the same. Hii haina en. En ndio hakuna. Kwa EWN is equals to what? Hakuna en. Tumepata en, right? venye tumechukua dn the desired minus yn. Yn ni wanaita yn nini? Solution. Shuka uone, it's not the same thing. Bushuka ndio hiyo yn, tunaona tumecalculate tukapata yes. En, yes. Shuka. Naona sasa imefanya different thing. En is equals to dn minus yn. Yn yake imeandika w.
W1, X1, what are these?
Yes. That's where the difference comes in. Wow. This is a completely different thing. Yes.
So,
hadi mimi ipate pale tumeshuka hapo tukasema en is equals to dn minus, hapo nimepotea kidogo. Ni definitions za hizo terminologies.
But so what are we substituting now?
We don't have anything we're substituting. I think the question should be an LMS filter has weight vector as follows. So the question is compute the output error and the updated weights wn plus 1. Umeradi hivyo hiyo inachanganya, tuachane nayo, hata we agree. Because hapo venye tumefika hapo chini, hapo ndio imeanza kuchanganya. We were going on quite well. Yep. A prayer, man. Then wajua hapa ni terminologies wanatupatia, the actual terminologies that should be there.
A coin toss experiment. Let Zi be manually indicative of which coin is used.
Yes.
GZ I is equals to 1, GZ I is equals to 0.
Mm-hmm.
So binomial with binomial distribution of
NP. With NPS. So our N is equals to 10 and our P, moja ni theta 1, ingine ni theta 2.
Suppose to observe data x1 is equals to 8. Estimate, current estimate that.
Mm-hmm.
Sasa shida. Unaona hiyo swali venye imeulizwa, hata ile ingine sikumbuki tulifuatilisha hadi IEM. Kila kitu inaenda kwa. So, tuone.
Hatusimia ni swali ya? EM, okay. Nione kama nitakumbuka. Ni equation tu tulikuwa tuna fit in.
Sasa hii tumepoa equation.
Sasa hapo ndo swali ilipo. Unaona hii ilikuwa ya normal, hii ni binomial.
Na equation yake iko wapi?
I think hiyo tunafaa kujiandikia si wenyewe the equation. Hadi hapa hatukupatiwa equation. All we were told is that it's a normal. Binomial inakuanga ni e power lambda to power x over x factorial, right? Hapana. Binomial inakangaje? N combination p to power x, 1 minus p to power 1 to power n minus x. Do haifai kuwa n, inafaa kuwa na n minus x. Oh, n combination x. Okay, yes. P to power x, that is correct. Wait, kwani wamedu hiyo swali, kwani wameisolve aje? Because like kama kuna kitu imesolviwa
hapa, hakuna kitu because this one ona hii hiyo vitu ya jamii na yalichoka, ona si tumekuwa vizuri sana. X1 is equal to
lakini if I remember correctly, wanauliza compute the conditional expectation of Z1 given X1 is equals to 8 for the first observation. The first observation is near X1. If we are to fit it back to this equation, kwa the equation ya binomial.
Let me show you very quickly something. That is the binomial equation, and coincidentally is what I've just opened. N combination x, px, qn minus x.
You remember when we were solving for E, tulichukua the distribution of the normal, when the value is x1 over you add the value x1 plus x2. That was to be the denominator. You remember?
Say again.
We replace in this equation. Sasa tunaona hivyo n combination x1 p to power x1 into brackets 1 minus p n minus x1. So this value over x1, yes, nx1 into brackets p to power x1 1 minus p.
I can't relate because I am not reading.
Ebu angalia, ebu open hiyo ya em yenye ilikuwa solved hiyo ingine.
Gani?
Iko page, inafaa kwa page gani? In the karibu the last pages. Achana na hii ya Rachel, ile ingine yenye TOE 5. Bado shuka. Is it si hivyo chini? Yes, here. Ndio hiyo. Panda juu. Yes, you see what we did? We did sasa this is the distribution. Unaipita? Wataka kusema the question? Okay.
Of course, that I relate now.
Okay.
Consider that due to using normal.
Tukakuja tuka replace hizo values kwa the equation, right?
So for x equals to 3, x equals to mu 2.
Yeah.
And tukaita f1. F1 3.
Yes. F1 of x, which the x is 3.
Tunasema si ni f1 3.
Yes.
F1 of x 3. X equals to 3.
And then from there tuka replace pia when f2 of 3 bado, right?
Bado unajua bado inasoma hii.
Yes.
Get me. Hii f2 hapana f2. So mu 2 at f3 we substitute here again. So ndio f2. Tukaweka 3 minus 5. Tukapata that.
Then tukakuja tukafanya nini? The probability function. ya F1
observation belongs to. So hii equation ndio tunafaa kuwa tunajua.
Yes, but then what have we been doing? Tumekuwa tukireplace values za x na values za value ya x for the in the normal, right? So hadi hii yetu tunafaa kufanya the same. We replace the values of x kwa this binomial, tupate ya x1 na tupate ya x2, and then we come we take ya x1 tuiweke as the numerator because tumeambiwa ikwe ni the first component. So value ya x1 tuiweke as the numerator over the value of the value of the first term plus the second term. Umeelewa hivyo? So now tulichukua pf of 1 over.
So what we need to agree, this equation inafaa kuwa aje?
That in this case we were dealing with a normal, right?
Yes. So
no.
For this step probability, for now for the next will be
itakuwa sasa the distribution ya binomial which is nx.
I agree. Huku juu zote tuna substitute the x. Because hata mkienda kwa swali kidogo tu. Kwa swali iko na x1, x2. So it's like we'll be having fx, I mean, is it probability by fx? This, whatever. Must we have probability at first? Probability fx,
yes.
fx1?
Yes.
Like we have probability f1.
F1 next.
F1,
Yes.
F1.
Yes.
F1, which our name is 1 there. And probability F2. Studio. F2 and our 2 in this case is. Tunasema ajaribu tu apitue hiyo swali. So and then sasa F2 at 5, so hii itakuwa 5 na hii itakuwa 8.
Yes. Very correct.
So the other one now, the inverse of P itakuwa 1 minus P, which is 0.4.
Yes.
1 minus P is equals to 0.4.
Sasa hii row 1 ndio inanichanganya kidogo. Inatumika wapi? Because our P, si unaona kuna hii row 1 is equals to 0.7 plus, theta 1, sorry. Theta 1 is equals to 0.7, theta 2 is equals to 0.4. Does that mean for P ya x1, does that mean we should use row 1 na ya x2 we should use row 2? Ama tunafaa tu kutumia P to ignore row?
I'm not even yet to see because sasa to start with tuko na NP binomial distribution pale.
Yes.
So like to start with, if I was to substitute our binomial equation pale, tutakuwa 10 combination
0.7
x. N combination x.
Yes, n combination x, yes, which is 8. Our x1 is an 8.
Nimesema 0.7 number.
Hii ni row 1. Si ndio hii? The theta 1. It's a binomial with parameters n and p. So our n is 10 and our p is row 1. Our row 1 is 0.7.
So let me say now, for example, even what you're asking. Not this one. This one is what we use for our first case. Like 10 combination. I mean for this p here, this p, this theta. It's our p here, np, which is our np here is the probability again.
Yes, sasa hiyo ndio pattern inachanganya. Me I feel like I can ignore the 0.6. Because sasa
0.6 ya p. By the way, we have p and we have theta.
Yes, haifai kukua hivyo. I think hiyo part wanatry kuchanganya. Hebu angalia kwa the solution tuone wamefanya aje, wametumia gani.
Lakini unajua hii solution si tumeona haijaka compute.
Oh, Ebu ukirun nipeleke mtoto wa susu. Don't wake up, you're going to fall. Mommy is disturbing, but mommy has to study, okay? Sleep, baby. Sleep. Close your eyes and sleep. I am getting a very sharp headache and sielewi what is happening with me. Okay. So niko na Panadol hapa kwa nyumba unless mtu akuwa amechukua. I think I'll take it. When x1 you're solving when x1 is equals to 8 and z1 is equals to 1. So I'm assuming this z1 yao ni the theta. Z1 ni 1. Inatoa wapi 1? Okay, bushuka. Ama hapo ndo mwisho. Wametumia when p is equals to 0.6 and 1 minus p is equals to 0.4. Tena wanasema likelihood at Jesus. Kwa hivyo tutatumia 0.7.
0.7 au tena?
Hapa p x1 is equals to 8 when x1 is equals to n p n combination p. So p n combination x, sorry. Alafu anatumia 0.7 as our p. So tumeignore p, ile p walikuwa wametupatia 0.6. Okay. Yes. Yes. And then akafanya hii ingine akapata 10 combination 8 0.7 power 8 0.3 power 2. Good. Tuende kwa ilikuwa imepatiwa as the row 2 as the theta 2. Acha kuangalia hiyo Esther, hiyo ukianza kuangalia itakuchanganya. Row 2 unajua sioni nini, unajua mimi nimedisplay sasa sioni swali hapa hapa nione na hii sasa tutakuwa pamoja, unaona row 2 was 0.4. Wacha niandike kando ndio niweze kudelete. Okay, unajua sasa nikidisplay ile siwezi ona sasa venye unaona hapa. So I'm trying to trace where is where. Wacha tu kwanza niziandike hapa pia. Na hapa tulikuwa tumeambiwa is binomially distributed. Then theta 1, then 10, and theta 2. So kuna kitu umeniambia ati ina assume, acha tuone ni nini hiyo.
So from here tumesema imechukua nini 0.6 yenye imetupea p, si ndio? Hapa. So of course that is that. So like now when you are coming to substitute here, the 10 combination x where x is at 8, si ndio?
Yes.
0.7 ilikuwa nini?
The row 1.
So
yes.
Tunatumia theta 1.
Yes.
And that hapa tunatumia at theta 2.
Yes.
Now unajua sikuwa naziona. So I was still trying to wonder around this kwanza.
Okay.
So where are we applying 0.6?
Me I'm choosing to ignore. Unaona inafaa kunichanganya at this point.
So in this case we are supposed to assume we use the theta 1 as theta 1.
Yes. And the theta 2 as theta 2. So sasa tushuke chini kutafuta the weighted likelihood. The weighted likelihood, unakumbuka tulikuwa sasa hapa they were very specific that the first component is the compute the conditional probability that x came from the first component. Okay? And our first component is the x1.
The first equation,
Yes.
Here 0.7.
Yes. So tutakuja tutasema hiyo value ya x is equal x1 over combination ya value ya x1 plus x2. Okay, hii ni solution. Hebu shuka chini tuone venye wamefanya. You see whatever we got in the first value, this is the w1, the weighted something hiyo takosa ukumbuka ufanye nini Esther? Hii mi naweza sema hii nimecapture what it means, how it's working. I can say nimecapture the point. Hiyo part ya pili ndio inataka kunichanganya.
So for EM we are using the PMFs as they are. Then we substitute given the first circumstance and the second. Then we divide, we use the W1 over W1 plus W0.
Yes.
The first one plus over that. So that is the answer.
Yes. So whatever you get, you multiply by 100 to get a percentage. And then you say that is the, you say Z1 given X1 is equals to 8 is... Yeah, but the good thing is we are understanding the concepts now, unlike before. You get, kama hii niko sure ikikuja Esther, hauwezi kosa kitu ya kuandika.
So the catch here is just to know the PMFs.
Yes. Hiyo yenye ilikuwa na maswali ndio hiyo. Yes.
Hii ni ile ya kwanza. Sasa hii ni ya pili. So hiyo ya okay. Ndio. Hii tumesema inangoja 5. This is waiting for 5. If it clock to hivi. Wenda hiyo. Unajua 6 ikifika haki hiyo ni 7 na 7 hiyo ni answer.
Yes.
Mungu wangu mimi nisikoroeke. Mungu wangu shuka Mungu. Fuatana tu, sijui kama tutasoma na hii.
Hadi ndio nilikuwa nikwambie tusome na hiyo tu once.
Ndio nimeona. Unajua sikuwa nafikiria zimefuatana.
Nilikuwa
tu nafikiria ni ndio nilikuwa napita.
Tuanze hapo. Let's do this. Hapana, tumeelewa quite a number of things, sister. Kalman tu ndio inatuchenga.
Innovation.
Yes. Lakini at least Kalman Gain tumeelewa nini tunafanya.
Kalman Gain tulikuwa tunafanya aje?
Kalman Gain si ile yenye tulifanya ya acha nikueleze. Let me get there. Kramarau. Oja. Kuna Kalman Gain tulifanya?
Ni Kramarau yenye tulisema mambo ya Fisher's information.
You mean?
Hiyo Kalman. Because I was very curious to know what that, even the winner field, and that's what I'll just dwell in what is here. Mimi nikipata tu maswali zangu nipate tu, is it 20 bucks? Ama nafaa nipate 25.
Kai. Kwa hivyo lecturer ataangalia, I really hope kuna mtu atakuwa ame-understand Kalman juu sasa si lecturer ataona the last 3 weeks hakuna kitu mtu amekuwa akielewa kwa class.
Hata yeye mwenyewe atakuwa akielewa hizo.
Amekuwa akizisoma.
Hata si kusoma, alikuwa analia na sisi, hiyo kitu ikija tu usijaribu kuuliza maswali.
Hebu kwanza tukishamaliza hizi za unbiased ni nini? Kuna swali nimespot hapa. Nitakwambia tuiangalia.
Okay.
Sawa.
So unbiasedness. So and the mean square error. X1 x2 up to xn be an IDD mean. For unbiased, okay, it's where the mean is supposed to be. It's about the mean. Expectation from the mean. Should like the population mean should be the estimators. The sample mean should be equal to the population mean. Essentially for unbiased estimator. Because if it is too far away deviating from the population mean, then it's already a biased estimate.
Yes.
Unbiasedness is where the sample mean should be equal to population mean. So even any proof that we'll be doing, tutakuwa tunaegemea kuonyesha that the sample mean is equal to the population mean. Yes, and that is why the first thing here, expectation xi is equal to mean. So like okay, of course for we are saying here, we are saying for a population x1 x2 up to xn, it has the mean expectation xi is the same as the mean, like the population mean. Tunajua ya sample mean inafaa kuwa a statistics expert.
Yes.
But tuna assume it should be portraying the mean, the sample, the population means. And the variance should be sigma squared. So we consider two estimators. You consider two estimators. The estimator the mu1. This is like sample size, if sample 1 and sample 2.
Yeah.
If you want to show now, so when you want to show whether each estimator is unbiased, right? So an estimator is unbiased if expectation of the mu hat, not Unajua mu hat sasa ni ile estimator. The mu ama expectation of x bar should be equal to the mu. X bar meaning the sample mean. Right?
Yes.
So the first estimator, mu1 there. So how do you show? Me, I think I feel like we should use our notes. They are more explicit.
Yeah, we can do that. Funga notes.
But we'll be very brief. Tutakuwa tunaangalia tu what exactly happened, a few things. Tuweze biasness is here. Tulikuwa tumeenda kwa kuprove.
Tukawa tumefika pata kuprove.
But even before we prove, tusome kidogo tu. So if x1, x2, xn is a random sample of size n, right? Taken from a population whose probability mass function is this. And where you see this is the theta, which is a population estimate. So we are assuming that when you have this population, this estimator t of this sample, it should equal to the theta or mu. So we are saying expectation of this t estimator equals to the sample mean, the population mean. Should be equal to population mean. So this property is called unbiasedness, right? But where it is not equal to the population mean is a biased estimator. And you are even able to show that the level of biasness is that estimator minus the whatever you don't know here.
The population mean.
The estimator, the sample mean minus the population mean. It should give you the bias, where it is biased. But essentially for bias and biasness is expectation of t is equals to theta, is equals to the population mean. So if, for example, here expectation of t tends to, it should always tend to the essentially the expectation of t, this estimator should tend to the population mean as n tends to infinity. Very correct. So you're told show that sample mean x bar is an unbiased estimator of mean. So you have a series of a sample, x takes one, you have to go with that sample, be a random sample. So that's what I was telling you here. Expectation of x bar is the sample mean. Should be equal to the population mean. And how do you show this? Expectation of x bar is the same as to say it is the expectation of these independent samples divided by the number of n. And now since x1, they are independent, so it is to say now it's like you're saying each of it, because when you open the if you see when you open the expectation x1 plus expectation x2 plus expectation xn. So if you open up the bracket, when you open up the bracket, so this one is to say since they are random drawn samples, they are IDD. So each of it will be mu. You are assuming each of it will be same as mu. No. You assign them to be mu's. So in this case, you'll have mu n times. Itakuwa mu plus mu up to n times. Hapo tukikuwa na 1 by n. So at the end of the day, you'll have 1 over n multiplied by n. So you have so in this case, expectation x is equals to mean here.
Yes, that is perfectly understood.
So hence, the sample mean x bar is an unbiased estimator. Like that.
Okay.
That's one way of how you show it. Let's just do this example. A random sample of 10 cadets of center selected. So this is a sample of 10 cadets. So remember now, this sample you are able to calculate the mean for these cadets here. which is our x bar, which is 63. But now, so hiyo tu sijui mbona ilifanyika tu expert. We know that the x bar is an unbiased estimator of the population mean and its particular value is unbiased. Because we had already proven, remember through this, what we prove x bar is already an unbiased estimator pale juu.
Yes.
So whatever sample mean here will automatically be the population. So you just calculate that sample mean. Now what you have to find now with a PDF here. A random x1, x2, xn of size n is taken from a population whose PDF is 1 over beta minus
exponential to power negative x over theta.
X over beta. Akimungu tu nayo chini. Kuna mahali tutapita tukipitia hizo PDFs data moja. Show that sample mean x bar is an unbiased estimator, right? So remember, for unbiasedness, we are still saying we want to assure that the moment we are doing, we are having expectation x bar, it should equal to the sum to the population mean.
Yes.
But hii naona hii already hatujapewa population, hatujapewa mean, so we always end up first to start to get to calculate. Every time ukiona nimepewa PMF, najua zile zingine nimepewa, lakini kwa hii ukipewa PDF, you end up first calculating for the mean and the variance. So, and how we calculate, it is usually the integral of expectation of x, where we introduce x, fx, x, fx. So you'll be multiplying x times the PDF.
All right.
So you get the integral. So you factor out the 1 over beta, then you integrate. With integration, can I remember this integration? Sasa hapa ndio nilikuwa nasema ilikuwa ina introduce kama. It's just crazy. Ilikuwa tu inanipoteza tu.
Yes, I think me understand venye hapa kulienda. Alisema an integral of x. Unaona hapa mwisho penye imeandikwa integral of x to power n minus 1 exponential negative ax dx should give you gamma n over a power n. So for us to make our equation ifanane na ili tuweze kupata gamma n over 8 power n, venye alifanya ni hii part ni x power nothing, right? So ili ikue in the form of n minus 1, akasema 2 minus 1. So at the end of the day it gives us 1.
Okay, let me ask, where is that? Where okay, you see, hapa 2 minus 1.
Yes.
Because it becomes a 1.
Yes.
Because we want to fit in
minus 1. Yes. But since hakuna anything, so tumechukua 2 minus 1 ili to make sure hatuja change the equation venye inafaa kukaa. So hii part ya x sio iko na the a is minus 1 over theta.
So inakuwa gamma 2.
Yes. So our a becomes 2. Okay. Our n becomes 2 and our x becomes 1 over theta.
It was already a 2 here.
No, there was no a 2.
Tulisema n is equals to 2 minus 1. Na sijui n minus 1. That's where it's coming.
Yes, I'm saying like initially hakuna kitu tumesolve. You have just made it to have a minus 1.
So that's what I'm saying. Not have a just en. N tumesema hapa yetu is the same as gamma 2 because how did our n become a 2? Because in the first instance hapa ndio he maintained the original equation. He said n is equals to 2.
Yes.
Tukasema 2 minus 1. That's what I
mean. Okay, yes.
You know where it emanated? It's not just a 2. Because if our initial equation here was x cubed, ingekuwa na
4 minus 1. Yes.
So your n will be 4.
Yeah. And then sasa when you replace gamma 2 over 1 over theta power 2. Hii part ni kukram tu. Lakini sasa mimi my big question was hii gamma 2 kwani is equals to 0 ama ni 1? No, it's not equated to anything. Ni after you have solved inakuwa is equals to 0. To theta, sorry. Like
remember our ultimate goal is a population mean.
Yes, but let's try and solve whatever we have. So 1 over theta.
You always assume that E is saying 6x1 x2 are randomly drawn from same population having mean theta, expectation x1, all that is equals to that. Yeah? So tuone hapa imesuluaje. Naona zile vitu wamefanya. So how has it now become? Naona hapa the x bar is equals to theta.
Okay, so tulipata pale our expectation of x is equals to theta after tumesolve hiyo equation iko hapo juu. Si ndio?
Hii unajua is arbitrary. I was comparing now with this yenye iko hapa juu. Hii tu unajua una drive, hii ni kudrive, lakini hii sasa hii tumepata nini hapa?
Ndio nilikuwa nakwambia to solve, ukasema tushuke. So over gamma 2, right? Hapa chini tuko na 1 over theta squared. Okay? So hii tukaileta juu itakuwa aje? 1 over theta times theta, sini una multiply by the vice versa, ama ndio tu multiply by theta squared kila mahali, by theta squared. So ina cancel out, so unaachwa na 1 over theta times theta squared times gamma 2. So hii theta denominator ina cancel out na 1 of the theta. So you are left with gamma 2 theta. So the question is, gamma 2 is it equal to 1? Ama how does it disappear?
I'm saying already unajua hapo already hiyo unaona wamefikisha hapo. That's what I was already asking. Na washasema is equals to
theta. Kumaanisha wao wamemalizana.
So tutafika hapa na wewe sasa tena ukuje
pia wewe uruke hivyo tu kaa wao.
Weke hiki kama hii. Vizuri sana.
So yeah.
For variance, S prime 1 over n, x1 minus x bar. This is biased, but for unbiased, ile tunawekaga 1 over n minus 1. Na hapo kuna kizungu, but let's pass at least tumeelewa concept.
Yes.
Twende kwa ingine.
My head is going crazy. Sasa hii ya poison inanishtua. Tunaweza fanya hii ya poison to prove that it's an unbiased estimator.
Okay. When you already have this, ile kitu utafaa ufanye tu hiyo tu kama estimate kwanza. So you use this, you introduce x. X fx.
Yes.
Then you integrate.
Okay.
You first get for integral ya minus lambda. Integral kai unajua hii just feel.
But iko mahali hapo mbele though. Iko kwa either consistency ama sufficiency somewhere.
So.
Yes. Example 6 iko page 17 hapo juu, but si solution. Hebu angalia uone venye wao wamefanya. Alienda tu direct, they didn't integrate. Page 17. Yes, hiyo yuko nayo. Okay. Page 17 is your, ebu shuka, sioni page number.
Kama ni page 17 ya namba za juu.
Okay, kuna namba ya juu na ya chini. Juu nimeona umepita umefika 18.
Kwa sasa, unajua sasa ya chini ni 20. Kwa mahali already, let's see. Because me, I'm already seeing the two one and then
18,
hapo.
Panda. Panda. Ndo hapo sasa. Ndo hiyo, if x1 is a random sample taken from a Poisson distribution, then show that the sample x bar is consistent estimate of lambda.
Unajua hii sasa tofauti ni hii hawajakupea PDF.
Yes, na hawaja integrate pia.
So hii yenye ya PDF lazima ufanye kama venye tumefanya hii ya exponential.
Yes.
So to calculate for your expectation of x. Right? No.
Yes.
Hii already najua wameenda to direct.
Nasema hivyo sasa ndivyo nimenotice wameenda to direct, so kaput.
And then you need to then show that x bar already have been guided. Show that x bar is equal to lambda. Already kina haujapewa, so you have to estimate it first. You have to calculate it. That's the difference.
I hope watatupatia tu hivyo that we don't have to calculate.
So we know that the mean and variance of Poisson distribution lambda are. Kwanza turudi huku juu kwanza tuone consistency. Ndio tukikuja si ndio? So actually wow, it is very confusing. So if x1 x2 is a random sample of size n taken by a population whose probability function is this. Beta is the population parameter. Then consider the sequence of estimators say. Ndio hiyo 6 inafika. Najua 6 kufika hiyo ni 7 tena tuanze kutembea kwanza mimi venye niko mbali. Yes.
Kuruka mbio.
Oh no, Jesus help us. So beta is the population parameter. Then consider sequence of estimators. T1 is equal to T1 x1. You know, like you consider various estimators T1, T2, T3. Like T1 x1, T2 x1 x2 all the way. A sequence of estimators is said to be consistent for parameters if the deviation of the values of estimator from the parameter tends to 0. A sequence of estimators is said to be consistent for parameter if the deviation of the values of estimator from the parameter, if the deviation of the values of estimator from the parameter tends to 0 as the sample size increases. That means values of estimators tend to get closer to the parameter
as sample size increases. Okay. Sisi class yetu hakuna venye tutaifanya sherehe ati after exam. Hata unaona venye tunaenda tuketi mahali tukule peacefully. It will never happen. Si ndio? Sasa hivyo ndo tungefanya huko. Kama unaona hii mara ya mwisho yenye tulikuwa na class on Sunday, we were supposed to go to the Airbnb, tupike. Tulikuwa tunafaa kwenda Airbnb, tupike, tukae chini tukule vizuri, tuongee. After exam iko. Lakini aki Mungu anisaidie next semester aki ni focus. Aki next semester Mungu akanisaidia ni focus, I'll be the happiest. Like after every class I take time to read. Aish. Oi. Yes, wakati ushaiangalia kitabu hivi kama umeniambia tu kuna wakati unakuwa umeniambia unakujua kwanza hii semester sikuwa hata na msichana ile class nimepitia wewe tumekuwa pamoja hapo nilikuwa na join research kwa hiyo Friday nilikuwa na join moja mtoto kwa bathroom na hiyo kila kitu mingi nilisikiza heri wewe mimi hata ni kuna class nilishawaingia sikuwa ningeanga ile technical appearance hadi nimeona sitati ya kuwa mzuri sana. I hope asiangalia attendance because mimi kiwa atanipea faa. Mi hadi sikuwa namjua hivyo. Mi namjua kusmailia msee, kuchekesha watu. Mimi nilishtuka. Kai. Ati don't talk to me. Go stay outside. Niko kwani nimekosea? Tuendelee. The sequence of estimators is said to be consistent for parameters. If the values of the estimator from the parameter, so if the values of the estimator from the parameter as size increases,